All right, finally ready. Here we go. Let me go over the answers to this worksheet. We're going to go over it. So I'm modifying what our lesson plans were at the beginning of the week. Okay, I was going to do the next section today, but I know that there's going to be a lot of questions on this worksheet, and so I thought we'd spend most of the time going over that today. And I'm going to give you another worksheet that looks very similar to this, just so we can practice it. We have an extra practice for it. Okay, so I will give you a second worksheet. If you didn't get the worksheet the first time, come see me. I mean, I don't have the worksheet on me. Does anybody have like a blank worksheet that they just didn't do that I could make copies? Nobody? Okay, I was just checking. Right, I mean, you shouldn't have a blank copy, but there's probably a couple of you that maybe didn't do anything on there, so I thought I might be able to use that to make some copies. But let's go over some answers, all right? This is not the most riveting video, but this is just for the people that aren't here. So on the first section, it says find the values of the 6 trig functions for angle theta. So what are they asking? What are the 6 trig functions? Remember them? The first 3 are super easy. What are they? Sine, what? Cosine, and tangent. Okay, what are the other 3? That's only 3. What are the other ones? What's the inverse of the sine? Cosecant. What's the inverse of the cosine? Secant. What's the inverse of the tangent? Cotangent. So that's what they're asking for, okay? If you didn't understand what they were saying, they're asking for the 6 trig functions to that particular triangle, all right? So that's what they are asking. I'll tell you what, let's just do one of them. Let's do number 1. And then I'll just read off the answers to the other 2. All right, so this is number 1 from the worksheet, 13.1 worksheet. Let's make a triangle. Where's my triangle? This is down here. Copy that. And then come back up here. And let's kind of make it. It's kind of rotated a little bit like that, and then it's a little bit skinnier, right? Does that kind of look like it? It's pretty close, huh? It is a right triangle. How do we know it's a right triangle? That little box right there. If it doesn't have the box, you cannot assume that it's a right triangle. Everybody hear me on that? There are times, like on the SAT or something like that, where they may have a triangle, and it might look like it comes to a right angle, but you cannot assume it unless they tell you that that's a right angle. Okay, it's very, very important that you understand that. Here's angle theta, this one right here. This is 24, and this is 45. All right, and you want to find the 6 trig functions. So again, what are they? Sine, cosine, tangent, and then cosecant, secant, cotangent. That's what you want to find. Well, let's write them down. So we just want to find the sine of the angle. We're not actually looking for the angle itself, right? We're trying to find the sine of the angle, and then the cosine of that angle, and then the tangent of that angle. What's the little device that you use to remember sine, cosine, tangent? Do you remember? Somebody say it to me. SOHCAHTOA. Nobody's stopped me in the hallway and said SOHCAHTOA to me. Remember I told you to do that? All right. Somebody do that sometime today. I'm in the hallway. Stop me and say SOHCAHTOA. All right. So what does this mean? The SOH. S-O-H. Why do we learn SOH? Because it's sine equals what? Opposite over the hypotenuse. Let's fill all these in. You don't have to do this part right here. I'm just doing it as a teaching method for you. What's the cosine? It's the adjacent over the hypotenuse. After a while, you're going to do so many of these things, you won't even have to go through that SOHCAHTOA thing. You'll just know it because you've done them so many times. The tangent is opposite over adjacent. Okay, now let's plug some numbers in. Right here, it's the sine of the angle theta. So this is the angle that I'm dealing with. So what is the opposite side to angle theta? Look at it. Which one is opposite? Is everybody looking up here? Got some people's heads down. Some people's eyes are not looking up here. I want everybody looking up here. Thank you. You've got angle theta right here. Which side is opposite angle theta? Is it this 24? Is it this one right here that we don't know? Or is it this 45? Which one is it? It's the 45. Okay, so that's the opposite. It's 45. Over the hypotenuse. What's the hypotenuse? I don't know. I don't know what the hypotenuse is. But how can we find the hypotenuse? You could call it x if you wanted to. Call it h for hypotenuse. Pythagorean theorem, exactly right. Okay, because they don't tell you all three sides, but I can find the three sides because it's a right triangle. They give me two sides, and I can find the third side. And so that's 24 squared. Remember, a squared plus b squared equals c squared, plus 45 squared equals, we'll call it h, and that's squared. I don't know what that stuff is off the top of my head, but guess what I have? I got a calculator. Watch this. I got to click on this first, I think. Where is it? Calculator, do I put, oh, there it is right there. Oh, okay, it's already good. So it should show up. Let me see if it does. Watch this. Yep. Look at that. Is that impressive or what? I got a calculator right there. This is what I used to use a long time ago when I taught math. And I looked online, I couldn't find it. Finally, yesterday, I spent a long time and I finally found it. So there's a graphing calculator. Of course, it's not working. Come on. You kidding me? It should clear it. I shouldn't have to. I didn't do that yesterday. Where's the on button? Right there? Nope. I usually hit clear and all that goes. There it goes. Oh, I know, because I wasn't using this thing. Maybe I got to press super hard on it. All right, so let's see what it is. It's 20. I'll use the mouse. There we go. Works better on the mouse. So 24 what? Squared, and then plus 45 squared. 45 squared. And then I'm going to figure out what that is. That's 2601. What do I have to do with that, though, to get h by itself? Because that's h squared. So I got to take the square root. So what I can do, man, it's been 10 years since I've used this calculator. There should be an answer. Where's the, is there a button that says answer on it? There should be. Where is it? Where is it? Yeah, but where's the answer thing? It should say A and S. Where is it? Hit second function, but where's oh, right there. There's the answer. Do you see it? Where that minus, that little minus is right there. So watch. So I'm going to take the square root. So I'm going to hit second function, that right there. So I'm going to take the square root of the answer, and I hit the answer by hitting the second key, that right there. I'll just put that in parentheses. See what it's doing? It's taking that 2601, then it's taking the square root of that, and that gives you 51. So there you go. So this, oops, there we go. So that's 51, all right? Now, if I just click on, will that go away? Do I have to completely move it off to the side? This is dumb. Let me just get rid of it. So I'm just going to exit it. Okay, there we go. All right. So what did I say this was? 51. Now the rest, that's the only real math that we had to do. Oh, why did it grab all that stuff? Oh, I know why. There we go. Let's move this over right here so I can have some room to put on my inverse functions. All right. Is anybody following me? Okay. So now let's do the, and that's part of our answer. That's 1/6 of our answer to number 1 because we had to put 6 things in there. So that's one of my answers. It's just 45 over 51. That's it. Well, actually, tell you the truth, I'm sorry. I shouldn't have done that. What can you do with 45 and 51? You can simplify. So what divides into all of these? 3 does. You ever learn a little trick? I was talking to Josh yesterday. He never saw this trick, but you ever learn the trick to see if 3 divides into something? If you take that 45, and if you want to see if 3 divides into it, what I do is I take those two numbers separately. 4 plus 5 is 9. Does 3 divide into 9? Yeah, you know that one, right? So that means if 3 divides into 9, then 3 divides into 45. All right? Anybody teach you that? No? Now they have. Okay, I have. All right, so 3 does go into 45. How many times does 3 go into 45? 15. All right. Does 3 go into 51? 51 seems like a weird number. It almost seems like a prime number, doesn't it? Because I don't have like a multiplication table where 51 is my answer, do I? But I could figure out, does 2 go into it? No. Does 3 go into it? Yes, it does. Why does 3 go into it? Because if I add 5 and 1, that's 6. Does 3 divide into 6? Yeah. So 3 divides into 51. I think that's 17, isn't it? Yeah. So it's 15 over 17. So that's how you should write your answer. You should always simplify your answers. Everybody got me? Okay. You writing this down if you didn't do it? Who thinks they did all these right? Numbers 1, 2, and 3. You think you did them right? Okay. This is just for the sake of the people that weren't really sure what they were asking here. So now the rest is pretty easy because now all I do is just look to see which one's opposite, adjacent, hypotenuse, and I can just plug that stuff in now. So cosine. The cosine of the angle is the adjacent over the hypotenuse. So that's 24 over 51. 3 goes into that 8 times. 3 goes into that 17 times. So that's the answer for that. The tangent. The tangent is the opposite over the adjacent. So it's 45 over 24. Make sure you simplify it. So again, we already figured out 3 goes into both of those. That goes 15 times, and 3 goes into 24 8 times. So it's 15 over 8. Pretty easy, right? Watch this. The inverse functions, which people sometimes don't like, but if you already figured out what the regular functions are, the sine, cosine, tangent, the inverse functions are actually pretty easy. So what's the cosecant of the angle? It's just the inverse of the sine. Well, we figured out what the sine was. It's 15 over 17. So guess what? We don't have to go back to this triangle. All we got to do is look to see what our answer was for the sine and take the inverse of it. So what's the inverse of 15 over 17? Just 17 over 15. So that's 4 answers. What's the, oops, I almost wrote sine. What's the inverse of the cosine? It's the cosecant. So I take the cosine, which is 8 over 17, and I just flip it because that's the inverse of it. So that would be 17 over 8. That's another one of our answers. One more and we're done. It's the cotangent. That's the 6 trig functions, and that's what you have to write down. So what's the inverse of the tangent? It's 8 over 15, and we're good to go. There's my 6 answers. So that's what you do for 1, 2, and 3. Now this was the easiest one because you don't have any square roots. But I'm not going to go through the whole entire thing on number 2 and 3, but I'm going to show you just a little bit of practice on how to simplify square roots because you're going to have to do that. So Josh, you'll help me out on like what it was before we simplified, right? So that's all I want. Okay, so for like number 2, that missing side. So you got one side is 5, one side is 11. So I'll tell you what, let's just do that part of it. And then I'll show you how to simplify the square roots. Let's put the triangle here again. Let's see, we're going to have to flip it. So I transform, I go to that thing. Let's see, flip it horizontal maybe? Nope. Flip it vertical. Let's try this again. Flip it. Nope, wrong way. Boom. Oh, flip it the other way. Let's try it again. There we go. That's going to look like it. So this kind of stretches out like that, and then it's rotated just a tad. So that's kind of what it looks like. So this is number 2. Would you agree? All right. So there's your triangle. This is number 2. I'm not going to go through every little step here, okay? I'm just going to go through the stuff that's a little more complicated with the square roots, simplifying the square roots. Now, we did this at the beginning of the year in the review chapter, but it's been a while, so I figured we'd do it again. And this is theta right there. I don't know why, but I always like to put that little arc there just to, I don't know, just like to do it. I don't know why. So what do we have to do? We got to find this right here. We'll call it x or whatever, or we'll call it s for side. I don't know, whatever you want to call it. We'll just call it x. So I know the opposite is 5. I know the hypotenuse is 11 this time. Remember on the first one, we didn't know the hypotenuse. We had to find it. This one, we're trying to find the adjacent side. So we don't know what that is. I still do Pythagorean Theorem. So let's do it like this. Let's go x squared plus 5 squared equals 121. I'm sorry, I got ahead of myself. I was thinking ahead. 11 squared. Okay? Everybody with me so far? Because it's a squared plus b squared equals c squared. This one that's over by itself is always the hypotenuse. So what do we get? We get x squared plus 25 equals 121. We got to get x squared by itself, so we subtract a 25 from both sides. What's 121 minus 25? What is it? 96? Okay. So that's 96. But that's x squared, isn't it? Right? So 121 minus 25 is 96. I got to get x, so x is equal to the square root of 96. We just use the positive version. Remember, usually you go plus or minus, but we use the positive because we're finding the length of something, so we just do the positive. Do I keep it the square root of 96, though? No, I don't. So what I need to do is take 96. Let's break down 96 so I can break down the square root right here. So like what times what is 96? Again, it's not one of those ones that just pop up in my head. But let's see. Does 2 go into this? Does 2 go into 96? Come on, somebody tell me. Yes. Why do you know that 2 goes into 96? Because it's an even number. Exactly right. So 2 times, what is that? 40. It's not 43. 48, right. So it's 2 times 48. Do I know what the square root of 48 is? No. Let's keep going until I can figure out how to break this down a little further. So this is just a 2. What about 48? What times what is 48? Okay, you can go 6 and 8. Let's do that. Or you could go 24 times 2. There's another one. But yeah, that's probably the easiest one, 6 times 8. Let's take 2. Let's break down 6. What is that? 2 times 3. Let's break down 8. That's 2 times 4, or what? 2 times 2 times 2. Why did I do all that stuff? Because I want to figure out what, anyway, let's just do this. I'll just show you. I got a 2 and a 3 right there, but then look at this. That's a 4, and that's a 4. 4 times 4 is what? 16 times what? 6. Again, 96 is not one of those numbers that just pops in your head and you're thinking, oh, 16 times 6 is 96. I don't know. I didn't know that. Did you know that off the top of your head? No, me neither. But you could figure it out. So watch what we're going to do here. 16 times 6. Why did I use 16? I used it on purpose because I could take the square root of 16 and it'll come out to a nice even number. Is that right? Yeah. So what's the square root of 16? It's just a 4. What's left over? Well, it's the square root of 6 is left over. So that is how we're going to write our answer. Okay, it's 4 square root of 6. Believe me, if you take an intro math class in college, okay, if you're a liberal arts major, do you know what liberal arts major means? It doesn't mean liberal conservative. It means nothing like that at all. Okay, it just means you take a major and you're going to take a lot of stuff, right? So if you're having spaghetti and you say, give me a liberal portion of spaghetti, what does that mean? Give me a whole bunch, right? So that's what liberal means, okay? So, kind of. Liberal arts means you take a bunch of stuff. So even if you're not even closely related to a math major, okay, or anything that has to do with math, you're still going to have to take a math class. And it's probably going to be something like this. It'll probably be a college algebra class. I think our college algebra was like Math 105 or something like that. I forget what the number was. But you'll probably have to take a college math class if you're taking a 4-year bachelor's degree, all right, liberal arts college. And you'll probably have to do this stuff. So this stuff is something that you may have to see in college. All right, let's do this. Sine, cosine, tangent, right? All that kind of stuff. So what's the sine? It's opposite over hypotenuse. That's easy. That's 5 over 11. What's the cosine? The cosine is adjacent over hypotenuse, right? And that's easy. 4 square root of 6 over 11. That's your answer. That's easy. What about the What about the tangent, though? And I'm doing this because of the square root, all right? What's the tangent of this angle? It's opposite over adjacent. So it's 5 over what? 4 squared is 6. Can we leave our answer like this? This is something we talked about at the beginning of the year. We cannot leave our answer like that. Why? Will the 4 divide into the 5? No. Will the 6 divide into the 5? No. What's the problem with leaving my answer like this? You can't have a square root on the bottom, okay? They don't like square roots on the bottom. Let's change this to a different color. So, what are we going to do? To tell you the truth, later on in your math classes, like if you're a math major and you go really a lot further in your math, they don't really care that you square roots on the denominator, okay? But for right now, a lot of teachers do. A lot of teachers will take off if you keep a square root in the denominator. So I'm just showing you how to do that. It's called rationalizing the denominator, all right? So let's get rid of that square root. We did this earlier in the year. So what do? We multiply the top and bottom by the square root of 6. Why? Because the square root of 6 times the square root of 6, the square roots cancel out, and I'm just left with a 6. That gets rid of the square root in the bottom. So we did what we set out to do, is to get rid of that square root in the denominator. All right, so let's see what we get now. On the top, it's just 5 times the square root of 6. On the bottom is what? What's the square root of 6 times the square root of 6? 6 times 4. Okay, we do that. This is kind of like in my head right here. So 4 times 6 is what? 24. So that is how we would write the tangent of that angle. And that's the answer they're going to give you. We good with that? All right, so that's how you do the tangent. Now, what about the inverse functions? Which one had a square root in it? The adjacent over hypotenuse. The cosine did, didn't it? Remember, the cosine was 4 square root of 6. The cosine of the angle was 4 square root of 6 over 11. So what is the secant of that angle? I know I'm kind of jumping around a little bit. I'm just trying not to do every single one of them, and it looks like I'm pretty much ending up doing every single one of them. How do I find the secant of this, of the cosine? Or what's the secant is the inverse of the cosine, so what's the inverse? It's 11 over what? 4 square root of 6. But we just finished doing one, so now we can do it a lot faster. Can I leave my answer like that? No. At least that's not the way they're going to leave it in the book. So, or in the worksheet. And I will give you the answers from the worksheet every time, so you'll know what the answers are. Okay, so the square root of 6, square root of 6. What do we get? We get 11 square root of 6 over 4 times 6, which is 24. Nothing cancels, and that would be the secant of the angle. That's about as hard as they get right there, okay? And the hardest part is not the sine, cosine, tangent. That's the easy part. The hardest part is just rationalizing the denominator, making sure that you write it the way that you're supposed to write it, okay? So there's a little bit of background for you. I went through it a little quick, but we have taught that before. If you need to go back to those review lessons, go back to YouTube, check out the page, and figure it out. All right. What I'm going to do now is I'm just going to read off on 2 and 3, and then I'm going to read off all the answers to the other ones, and then we're going to go through some more questions on this, and I'm going to give you another worksheet to work on that's very similar to this, a little easier, to tell you the truth, and then you should know what you're doing on the second worksheet. So let me just read off number 2. Let's read them off, even though I read some of them. So the sine of the angle is 5 over 11. If you didn't get it right, write it down. So you can always go back and check and try to figure out how to do it correctly. The tangent is 5 square root of 6 over 24. We did that one. The secant, I'm sorry, let's go, oh, they do it in a weird order. Okay, let's go cosine. The cosine is 4 square root of 6 over 11, which we already mentioned. The tangent is 5 square root of 6 over 24. Now the inverses. The inverse, the cosecant, is 11 over 5. The secant is 11 square root of 6 over 24. 11 square root of 6 over 24. We just did that one. Then the one we didn't do was the cotangent, and that would be 4 square root of 6 over 5. 4 square root of 6 over 5. So that's what you write down. Those are your answers. You get 6 answers for that one problem. All right. Number 3. Oh, number 3, they even give you. No, they don't. Did they give you all 3 sides on number 3? Yeah, because I'm looking at the answer sheet, and they actually do give you that 3rd side on this one. But they don't for the other 2. That was weird. Anyway, the first one, sine. On number 3, the sine is just 1/2. 1/2. The cosine is the square root of 3 over 2. Square root of 3 over 2. The tangent is the square root of 3 over 3. Girls, you writing all these down? Checking all your answers? Come on now. Write them down if you didn't get it. Write it down. Okay? If you don't have the worksheet, write down the answers. I'm giving you the answers. You shouldn't be talking. Sorry, I'm in a bit of a mood today. Could you tell? Yeah. But you're going to have to deal with it. So what did I give you? The tangent already? Square root of 3 over 3? Yeah. The cosecant is just 2. Cosecant is 2. The secant is 2 square root of 3 over 3. 2 times the square root of 3 over 3. And the cotangent is just the square root of 3. Cotangent is a square root of 3. I gave you enough information on that last problem to be able to figure out how to get number 3 right, okay, with the square roots and all that kind of stuff. All right, now with the real stuff. This is what we really came here for today, was to learn how to solve for the missing parts, okay, missing angles, missing sides, and that's what they're going to ask you to do. Notice, when you find the missing side, you round it to the nearest tenth. But when you find the missing degree, okay, the angle, you just round it to the nearest degree. Everybody understand that? So the side has to be rounded to 1 decimal place. That's the nearest tenth. And the degree, the nearest degree, you don't put any decimal. You just have to round it. If it was 32.9, what would your answer be? Come on, play along with me, please. Act like you're here. If it was 32.9, what would your answer be if you in your calculator you got 32.9 as an answer? How would you write it on this worksheet when it says round to the nearest degree? What does 32.9 round to? Thank you. You're alive. I can't believe it. Okay, I woke you up. All right. Number 4. Let's see, you just had to find the missing side, correct? Yes, x. So it's 4.0. And some of you are thinking, why do you need to put 0.0? Because it says to round to the nearest tenth, all right? So the tenth, you got to have a decimal place. If you just put a 4, technically that's wrong because you didn't round it correctly, all right? Remember when you were a little kid, you had problems where you had to round it. If you didn't round it right, you got the problem wrong. That's why they did it back then, so now you knew how to round stuff. Number 5, you had to solve for x, and it's 10.9. 10.9. Now, these are not equal to, Josh, you'll remember this because Josh didn't like this part, but these are approximations. So if I put it in a calculator and get some long decimal and then round it, they're not exact answers. So don't put x equals whatever, 3.2 or whatever number it is. Don't write that because it's not equal. Okay, it's approximately equal. The little squiggle equal signs, okay? And then you could put 3.2 or whatever. Everybody with me on that? Again, I probably would not mark it wrong if you didn't put the squiggly thing, but to be precise, we need to do that. All right, number 6, right, is 14.8. X is approximately equal to 14.8. Number 7, X is approximately 37.1. 37.1. Number 8, it's an angle, so we round it to the nearest degree. So it's approximately 48 degrees. And again, it's an approximate because you probably got more decimals after it and you had to round it. So it's 48 degrees. Number 9 is 27 degrees, approximately 27 degrees. All right, let me read the rest of them. By the way, did you notice number 16 is kind of cut off? So don't worry about number 16. I don't know why it is, but it was. Number 10, let me read these. It says, solve the triangle. I mentioned this to you. Was it yesterday? No, Monday. Monday, I mentioned to you, when it says solve the triangle, it's basically asking you to solve all the missing parts. Okay, find all the parts that are missing. So on number 10, you had to find angle B, and that would be 55 degrees. Again, we're rounding it the same way as we did the other ones. So angle B is 55 degrees. That's actually equal. You could actually figure out that that's exactly equal to 55 degrees. But side B is approximately 17.1. So B is 17.1 and C is approximately 20.9. 20.9. That's number 10. Number 11. A is exactly 19 degrees. Angle A is exactly 19 degrees. Side A is 8.6, approximately 8.6, and side C is approximately 26.4. 26.4. Number 12, angle A is exactly 54 degrees. Side A is approximately 6.5. Side B is approximately 4.7. You should be writing these down. Okay, if you got it right, you don't have to write anything down. Just put a check mark or something by it, whatever, just so you know you got it right. If you didn't get it right, put the correct answer down, and then we'll try to figure out where you went wrong. Number 13, angle B. Now, these are approximates. Angle A and angle B. Let's do angle A first. Angle A is approximately 30 degrees, and angle B is approximately 60 degrees. And then side C is approximately 8.1. Again, squiggle on these. Even on the answer key, they put little squiggle equal signs. Number 14, angle B is exactly 73 degrees. 73 degrees, it's equal to. Side A is 0.9, 0.9. 0.9 is fine. And then side B is approximately 3.1, 3.1. All the sides are approximates. Yes, sir. We will. Let me give you the answer first, and then we'll do a couple of these. So number 15, angle A is approximately 33 degrees. Angle B is approximately 57 degrees. Side A is 79.5, approximately 79.5. So 33, 57, 79.5. All right. Was this quarter of? Is today quarter of? Okay, 10 minutes. All right, let's do some of these. Let's kind of work our way up to 15 because 15 is a little bit tougher than the other one. So let's do like 10 through 15 because if you can do 10 through 15, you can definitely do 4 through 9. All right, so let's pick a basic one from 10 to 15 where you didn't have to, where you got an exact angle. Let's just do 10. Okay, and here's our triangle. Oh, got to flip it. Why did it flip that way? Oh, yeah, that's the way I wanted it. That's why. Of course. So let's push this off to the side. So we're going to deal with this triangle. And let's put some letters in here. This top one is A. This right angle is C. And this is B. And notice, that's supposed to be a capital A right there. So notice that the side opposite angle A is side A, so it's little a. The side opposite angle B is little b, and then the side opposite angle C is side C. So that's how they usually do that. All right, so number 10 says that angle A is 35 degrees, and side A is 12. If you wanted to redraw a different triangle every single time, you could do that. That would be fine. But let's just put it in here, and I'll just erase. Tell you what I'll do. Let's do this just to make this a little bit easier. I'm just going to copy this, and now I can just erase it and then paste it, and I'll still have those A, B, and C things. All right. What did I say it was? 35? Yeah. So that's 35 degrees, and side A is 12. And you need to solve the triangle. It says solve triangle ABC. So you're going to find all the missing sides. Well, we know angle C. What's angle C without doing any math at all? It's 90 degrees. You don't even have to put that in there because it's already given to you that it's 90 degrees. So we don't have to solve for C at all. We just have to solve for angle B, side B, and side C. Well, let's do angle B. Angle B is the easiest one. So how do I solve for angle B? Well, we just take 90 minus 35. Remember that? Okay, that's pretty easy. And what's that, 55? And it's equal to, notice I put a regular equal sign because it's exactly 55 degrees. Now let's solve for side B and C. And I'm going to use trig functions to solve for all of these, because once I get B, I technically probably could use Pythagorean Theorem to solve for C, but I'm not going to use Pythagorean Theorem. I'm going to use the trig functions every single time, all right? So let's solve for side B. Well, this is our angle that we're dealing with. So what is side B to this angle? This is where we're getting into it, okay? This right here. If you haven't listened to anything I've talked about today, now is the time to listen, all right? Because this is where we're really using all that stuff that we learned before and putting it into practice and solving for a missing side. So this side is what we're solving for because I want to solve for B. And this is the side that I know. Well, let's take a look at these two sides in reference in comparison to angle 35. What is the 12 to angle 35? Is it opposite, hypotenuse, adjacent? Which one is it? It goes opposite, right? So that's opposite. What is side B to this 35? It's adjacent. Which trig function uses opposite and adjacent? Go through it in your head. SOHCAHTOA. Just do it in your head. SOHCAHTOA. Well, the so and the ka both have hypotenuse in it, right? What's the one that doesn't have? The toa, the tangent, right? So it's not so, it's the tangent is what we're going to use. Because that's the biggest question people say, Mr. Hamrick, I just never know which one to use. Well, which one do they give you and which one are you trying to find? If you find those two sides, then you know which trig function. This is the opposite, this is the adjacent. Opposite and adjacent go with tangent. That's the one that we use. And I'm not going to put tangent of theta because I know what the angle is. It's the tangent of 35. And now let's put them in here. It's opposite over adjacent. So the opposite is 12 over the adjacent, which is B. Now we have to solve for B. We did this on Monday, didn't we? Remember that? I got to get B by itself. How do I get the B out of the denominator? I multiply it by B. So what do I do to the other side? I do the same thing to the other side. The B's cancel out. I taught this Monday, so go back and watch Monday. Just going to go a little quicker here. So this is what we have. But I got to get rid of that tangent of 35. I got to get B by itself. Remember, tangent of 35 is just a number. I stick it in a calculator, I get a decimal number. It's just a number. How do I take a number that's being multiplied by this? How do I get rid of it? I divide it. That's right. So I divide both sides by the tangent of 35. So I've got 12 over the tangent of 35 degrees. Now I just stick that in my calculator. Just happen to have a calculator. So I think on the recording, the calculator is actually going to cover up this stuff for reasons. Okay. See right there? See, it's covering it up. And I can't, well, actually, I could move it. Look at that. I'll put it right in the middle. All right, so I could change it, so that's good. Anyway, there's reasons why it does that. Anyway, let's do this. It's 12 divided by, so if you have a graphing calculator, this is how you would do it. And I'll talk you through the, if you have like a regular scientific calculator. So it's going to be 12 divided by the tangent of 35. So I hit tangent right there, then I hit 35. Yes, sir. Sure. And then I hit equals, and then bam, there it is. Give me just a sec. All right. We're back. I should have paused it, shouldn't I? So this is a side. So how do we round this thing?
Whoa.
Where did what? What did I do?
No, they weren't here when you showed them the calculator.
Oh, okay. So 20, I was like, what did I just do? So it's 25.3, right? And then do we just keep it 25.3? Do we round it up to 25? What do we do? It's 25.3 because look, that 3 doesn't round that 5 up, right? I don't have to go through that, do I? Okay, so it's 25.3. Whoops, 25.3. All right, so that's side B. We'll just keep that there for the next one. Let's solve for C now. Again, let's go through the stuff. I would not use side B to find side C. Use the original stuff that they give you because side B is an approximation. It's not an exact answer. Would you agree? Because we rounded it. It's got a lot of stuff that could go there, but it's not. So we just rounded it to make it nice and easy for us. So don't use one of your approximations to do the next part. Don't use Pythagorean Theorem because you're still using an approximation if you did that. Use the original information that they give you. So let's solve for C, which is the hypotenuse. So let's take a look at it again. What do we have? We've got opposite. Go ahead. Did I do that wrong?
Side B, I had 17.1.
You did?
The side not. So if you do 12 divided by tan 35, you get 17.
What did I do wrong? 12 divided by tangent of 35. So you put this in your calculator and you got 17. Do I have this in degrees? Oh my gosh, it's been 10 years since I've used this calculator. Where's radians in degrees? I think you have to go to menu or mode. It's in radians. Do you see that? See radians. So you got to hit this thing, right? So go down one. So thanks for letting me know that. I appreciate it. And then hit enter. There we go. Okay. And then how do I get back out of that? Do I hit clear? There we go. Yeah. And then you should get 17.1. Okay. So here's what I'm going to have you do. Listen, everybody watch. Listen. Just wait a minute. I'm gonna have you finish up that worksheet if you didn't finish. If you finished it, then that's no big deal. If you didn't finish it, I want you to finish it. You know what the answers are now. Get them right, know how to do it, and then I want you to work on this worksheet. Okay, so here is a new worksheet for you. So this is your homework for tonight, okay? This worksheet. It's still 13.1. It's called skills practice instead of just practice. So that's it. Put this on that table right there. Put that on. I just said, hang on to it. I just said it. Hang on to the old one, even if you got them all right, and even if you finished it. I will take it tomorrow. I'm going to take them both tomorrow. Okay.